Hydraulics. Let's review the basic principles. Hydraulics is the science of transmitting power by applying force on a confined fluid. Its working principle is based on a law discovered by a French scientist named Blaise Pascal in the 1600s. Before studying Pascal's law, let's look at the relationship between pressure and force. Pressure is defined as the force acting on a unit area. It may be expressed in pounds per square inch or PSI. Let us work out the relationship between pressure, force, and area. This can be easily understood by using the pressure-force-area triangle shown in the figure. When pressure is unknown, it is calculated as force divided by area. Similarly, when area is not known, it is calculated as force divided by pressure. When both pressure and area are known, force is equal to pressure times area. Pascal's law states that pressure created in a confined fluid is transmitted undiminished in all directions, and it acts with equal force on equal areas and at right angles to them. How does Pascal's law work? The following example of a glass bottle filled with fluid clearly illustrates Pascal's law. A small input force is applied to the stopper. Pressure equal to the force divided by the stopper area is created in the fluid. In this case, it is 10 pounds per square inch of pressure, as we have applied 10 pounds of input force over an area of 1 square inch. According to Pascal's law, this pressure is then transmitted through the fluid undiminished in all directions. This pressure acts against all equal areas of the bottle. The resultant output force is multiplied in this example over the 20 square inches of the bottom of the bottle. In this case, an output force of 200 pounds is generated with an input force of only 10 pounds. Due to this increased force on the bottle breaks. What will be the value of pressure developed if a force of 50 pounds acts on an area of 10 square inches? The hydraulic press uses the principle stated in Pascal's law to multiply force applied on a small area to a bigger force from a larger area. Let's see how Bramah, a British mechanic, applied Pascal's principle to the hydraulic press. A force of 10 pounds is applied to a piston area equal to 1 square inch. The resultant system pressure is then 10 pounds per square inch or 10 psi. This pressure is transmitted undiminished through the fluid and acts on the bigger cylinder whose area is 10 square inches. The resultant upward force on the bigger cylinder is 100 pounds. As you can see, we have balanced the load of 100 pounds with only 10 pounds of input force. The hydraulic brake used in motor vehicles is another example of multiplication of force using hydraulics. Here, a small force applied on the brake pedal piston, whose area is small, transmits the resultant pressure through the hydraulic oil. The force is multiplied by the brake shoe piston, which has a larger area. This multiplied force is enough to stop a moving vehicle. The law of conservation of energy states that energy can neither be created nor destroyed. The multiplication of force in hydraulics gives the impression that energy is being created because of force multiplication. This is not the case, however, as energy is measured in terms of the amount of work done. Work is defined as force times distance. The given example illustrates this principle. Here, a force applied on the smaller piston is sufficient to move the bigger piston. However, it must be noted that the smaller piston must move 10 inches to move the larger piston only 1 inch. Hence, the amount of work accomplished, or force over a distance, is the same for both pistons. This proves that energy is not created even though force is multiplied. The distance each piston moves is inversely proportional to its area. From this, we infer that what is gained in force is sacrificed in distance.